Hey, Paul.
Happy.
This meeting is being recorded.
Yes.
Today's lesson really isn't so much a lesson, it is just more examples of solving non-linear equations using elimination or whatever. So let's just jump in and kind of go through a few of these. Are there any kind of remaining questions from Footage Friday that need to be solved?
I have a question, Mr. Reyes. Do we always have to draw the graph before we calculate? Because I had some trouble drawing some of the graphs.
No, you don't always have to draw the graph. Like
Okay.
those log ones were a little bit tricky. Definitely it's not a bad idea if you can. I mean, boy, looking at example number 2, that first one, I don't want to graph that thing. So I certainly am not going to. It's a good idea. It gives you an idea of how many solutions and where to look for them and whether or not the solutions seem reasonable. But all said and done, probably not. If I were to look at this first one and try to graph it, the second one is nice and easy because that is the graph of a circle with radius 5 centered at the origin. Another point on that first equation would be if x equals 0, y has to equal 19. Really, I would want to write this as y equals negative x squared plus 19. So it's going to look like that, and I have a feeling that it's going to open up too wide, kind of do that kind of thing. But I could be totally wrong. Let's run the numbers and give it a shot. I am going to subtract the top equation from the bottom equation. So x squared minus x squared, no more x squareds. And I'll end up with y squared minus y equals 25 minus 19 equals 6. This looks a lot like one of the ones we did on the other one. In fact, when I started to redo those problems, I think I grabbed this packet and was like, oh wait, that's not it. Y squared minus y minus 6 equals 0. How about a y minus 3 and a y plus 2? This pen is not being my friend. It looks like it is solvable, but still remains to be seen, I suppose. So y equals 3 or negative 2. If that is the case, I think that x should equal 4, just taking advantage of a 3, 4, 5 triangle here. How about plus or minus 4? Ooh. And if y equals negative 2, then that is 4, and I think I'm going to end up with plus or minus root 21. Okay, so my drawing's apparently kind of on the lousy side. It looks like this thing is still going to be narrow enough to kind of go in and out of both of these. It's a fair amount of symmetry. I have the points plus or minus 4 comma 3. So that would be this one and that one. And on the way out, the plus or minus root 21 comma negative 2. Sound okay?
Have to graph it.
It's not a bad idea to graph it. You technically didn't have to. My graph kind of was misleading. I thought I was going to miss, but I hit. It does make some sense. Hi. In example number 2, what's going to make it both a sticky widget to graph and to actually do is this XY business. So that's what I'm really going to strive to get rid of. If I add these two equations, it goes bye-bye pretty quick. So I'm adding these two equations. I'll end up with x squared minus xy, but plus xy, those go away. Plus x and minus 12 equals 0. How about an x plus 4 and an x minus 3 equals 0? X equals -4 or +3. Now that I know what x is, I can plug back into the easier equation to solve for y. I'm guessing it's going to be this one. So I've got -4y minus 4 plus 6 equals 0. -4y equals, looks like a -2. Y equals 1/2. So there's a point, -4 comma 1/2. And my other one would be when x equals 3. So I end up with 3y plus 3 plus 6 equals 0. 3y equals -9. And y equals -3. So my other point is 3 comma -3. And do these both work? I plugged into this one, so yes. I plug in here, I get 16 plus 2 minus 18 equals 0. That will work. I think this one will as well. So I'll end up with 9 plus 9 minus 18. Yeah, both of them. So far, so good. All right, why don't I give you guys a moment or two to try the next one. I will start off with the hint that I'm going to write off to the side that A equals 1 over x squared, and B is equal to 1 over y squared. Do we get an answer for example 3? I got some nods. Does it involve a square root? I got some nods. Okay. I got an answer of plus or minus 2, plus or minus square root 2. Getting a thumbs up from some people. Yes, yes, yes. Okay. Technically, this is not an appropriate way to list the answer, because how many answers are there? 4. Yeah, I could go plus 2 plus square root 2 minus 2 plus square root 2 plus 2 minus square root 2 and minus 2 minus square root 2. Mathematically, if the order has to follow. So this is kind of saying the plus goes with the plus, the minus goes with the minus. But so what? We'll call it good. I'm not going to over worry about something like that. Moving on, this one kind of looks a little bit on the familiar side. I'm going to say natural log of x equals the natural log of y to the 5th. And from that equation, what can just go away?
Natural logs.
Yeah. So I really have x equals y to the 5th. This equation I'm going to write as the log base 2 of x equals the log base 2 of 8 plus the log base 2 of y squared. Okay, so a little sneaky there. How did I get log base 2 of 8?
Because log base 2 of 8 is 3.
Because log base 2 of 8 is 3. I wanted to have everything written as log base 2 of 8s. So now I can just cancel out the log base 2s. That's a trap, people. I can't just cancel out the log base 2s. What do I have to do
You have
first?
to like make them like log base 2 of 8 times y squared.
There it is. So the log base 2 of x equals the log base 2 of 8y squared. X apparently equals 8y squared. Yeah. How about the transitive property, which you might know as the substitution property? X equals this, x equals that.
Can you move it down, please?
This equals that. Y to the 5th equals 8y squared. Where do I go from here?
1/5, like 5th root of both sides.
Y
5th
to the
root
5th
is going to make this super ugly.
y to the 5th equals y to the 16th, and then get rid of the y's.
Y to the 5th equals y to the 16th. There's no log. I can't make the coefficient into an exponent.
Can you divide by y squared?
Yeah. Can you divide?
Okay, if I divide by y squared, which is the closest answer I've heard to something that I like, I will get one of my solutions, but I'm also kind of eliminating something. So allow me to write it over here where I have a little bit more space. And I'm going to write y to the 5th minus 8y squared equals 0. And I'm going to factor out that y squared, which is
Can you move
something.
it down?
Yep. Which is something like dividing it out. Sorry, that is emailing me. And now I can see that y could equal 0, which sounds great and all that until I look up at my original equation and realize y can't equal 0. Doesn't work. You can't take the natural log of 0. But y cubed minus 8 could equal 0. Difference of cubes. How about a y minus 2? A y squared minus, no, plus, same different plus. 2y, always end with a plus. 2 squared is 4 equals 0. So y could equal 2. Does that jive with what we had up at the top? Can you take the natural log of 2? And the log base 2 of 2 for that matter? All of those are yes. And can this equal 0? Check the discriminant. B squared 4 minus 4ac. It's going to be imaginary solutions. I think my only real solution right now is y equals 2. If y equals 2, what does x equal?
2 to the 5th.
32.
32. Yeah, so I think my answer is 32 comma 2. Let's check here. The natural log of 32 equals 5 times the natural log of 2. Seems right to me. Remember, we can go make that a 2 to the 5th. And the log base 2 of 32, which is 5, equals 3 plus 2 times, the log base 2 of 2 is 1, 2 times 1 is 2, 3 plus 2 is 5. All seems to work out for me. So there it is. And sorry, it's kind of all over the place on that one. I don't know if any of that's legible, but hopefully. You guys have a good weekend? Got some nods, got some nods. Savannah, did you do anything for your birthday in quarantine?
Not yet, but I'm doing some stuff after school when I'm done.
What are you doing?
Well, I'm not like really supposed to know, but like all of my friends are like doing it, like they're all like coming to my house and like driving by my house.
All of your friends? Like both of them?
Like a lot of them.
Oh,
I don't know who's coming though. It's like a whole thing.
that's pretty cool. That is pretty cool. You know, I mean, as much as people gripe about this and they're like, oh, I feel so sorry for the seniors and all that, I always think, you know, at least it's memorable. I mean, I don't even remember my 15th birthday. I had a picture on Facebook of my 17th birthday. But that's a different story. Okay, example number 5, a little bit of sneakiness going on, I think. Ooh. Actually, example 5, who knows? Let's jump in and give it a shot. Do we want to multiply by, Okay, so here are my different thoughts. What would happen if we just subtracted as is? The x squareds would go away, and we'd be left with something with an xy and a y squared. Seems pretty ugly. Why don't I multiply this guy by 3? So I'm going to rewrite the top equation exactly as is. X squared minus 3xy plus 2y squared equals 0. And I'm going to multiply the second equation by 3. So I'll end up with 3x squared plus 3xy equals 18. With me so far? I got 1 or 2 nods and something randomly went ding. Okay. Now what should I do with these 2 equations?
Add.
If I add them, then I get rid of that cross term. I get rid of that xy term. So I'm going to end up with 4x squared, unfortunately, plus 2y squared equals 18. What is this thing?
A circle?
Close. If they had the same lead coefficient, it would be a circle. It's like one of those circles which one side got stretched.
No
Like
lips.
An ellipse. Yeah. So the standard form of an ellipse, and by the way, how many solutions are there to an ellipse? There are an infinite number of solutions. So I'm kind of interested to see what's going on here. Okay, a ellipse in standard form is where I divide both sides by 18 and equals 1. So if I divide by 18, what am I going to get? I'm going to get x squared over 4.5. Does that sound right? Plus y squared over 9, and that definitely does seem right, equals 1. Yuck, this is just super ugly. I mean, but there it is as a solution with an infinite number of points. I don't know. Let's take a look. Let's kind of switch gears, and I'll bring it up on Desmos. We'll give it a shot there. Let me just this video and that video. Exit full screen. Come back here. Share screen. All right, so plugging this thing in, xx minus 3xy plus 2y squared equals 0. All right. That is, I don't know what that technically is. It kind of looks like a hyperbola a little bit. Xx plus xy equals 6. Okay, so there's my hyperbola, but we only have a finite number of points on this thing. Interesting. Okay. So, where to
Wait, but
go?
don't hyperbolas have asymptotes?
Hyperbolas do have asymptotes, and I
So
can.
then it couldn't be infinite.
Well, it can be an infinite number of solutions. Remember, anything which is like a continuous stretch has an infinite number of points on it. It doesn't look like it was going to be this. It is not. Let's go with that first thought. So I'm going to switch back to that other screen here. I do remember, by the way, this one as being a particularly tricky one from last year. Just, you know, nothing that you would expect to actually see on a test or quiz. But let's try that original thought where we subtracted. I'm going to write it as the bottom one minus the top one. So I've got x squared minus x squared. Xy minus negative 3xy is now 4xy minus 2y squared equals 6. Or how about 2xy minus y squared equals 3. Solving for this in terms of x, I guess. 2xy equals y squared plus 3, and x equals y squared plus 3 over 2y. Okay, doesn't really get us any closer. I don't know. We might end up leaving this as one to grow on. As I said, I seem to recall it was a sticky one last year as well. I might have to pause and think about it a little bit, which is not the worst thing in the world. Okay. So aside from this one, which leaves some more work to be done, how did the rest of them feel? Oh yeah, Maddie.
Sorry, my Wi-Fi like stopped working in the middle of example 4. Could I just see it for like 1 second?
Of course. Additionally, I know that it only comes out in standard definition. Oh, there's another one. It only comes out in standard definition, but I do make videos out of all of these. So we ended up getting 32,2 as our answer. Were you with us when we rewrote 3 as the log base 2 of 8?
Yeah.
Okay.
It broke when we got to like y squared times y to the third. Yeah.
Minus 8 equals 0. That is the difference of cubes, so we factored it there. There's an easy solution to this part, and there's no real solution to that part. So we ran with that because that was the only answer in the domain.
Okay, thank you.
Oh, you're so welcome. Okay. All right. Well, we can call it a day here.
Mr. Reese, what is your quiz going to be on?
The quiz is going to be on all of this section of Unit 11, I guess. Tomorrow we will cover inequalities, but then it'll be just the linear systems and nonlinear systems, and I believe linear inequalities and nonlinear.
Would you be able to give us like a review packet for it?
Yeah, I will send you one right now.
Mr. Reeves, can I see number 3?
Number 3. Number 3, I gave the hint that a equals 1 over x squared, b equals 1 over y squared. Went through and solved for a and b, and then resubstituted back in to solve for x and y. We actually ended up with 4 solutions where x could be either positive or -2, and the corresponding y values were either positive or negative or √2. While you're looking at that, I'm gonna see.
Mr. Reeves, do you still want us to do the homework that you said was off, or the other homeworks?
So I would definitely look at those other homeworks, make sure that you know how to do them, but you know, a lot of it is just stuff that you've seen before, so I wasn't entirely worried about that.
So you're not gonna collect it?
I'm not going to collect the old homeworks now.
Will word problems be on this quiz as well?
That came from Owen Kim. I was expecting that one from Paul. Yes. We'll presumably see some word problems on the quiz. I'm looking at the supplementary problems that I'm about to send you, and there are 1 or 2 word problems in there. In fact, 3 or 4. Okay. So I'm going to send these on, and let's see, we'll Control C action here, and Control V. These should be arriving real shortly. Faculty, my classes, Algebra 2 with analysis, students, email class, and paste that. Got it. All right. So sent. Okay, guys, if you do have questions, feel free to loop back. Other than that, I will see you tomorrow in class.
Thank you.
You're welcome. Have a good one.
Thank you.
You bet.